Hey guys, Nick from KN Tech, welcome back. So in my last video, I was doing some comparison between some older video cards and some modern video cards, just to see how usable the older ones are by today's standards using some modern titles. So in this video, I'm going to be seeing if we can get some more performance out of an older card, just so that we can make those last a little bit longer before we have to upgrade. So I'm going to be using a 1060, it's the 6GB GTX 1060 by Gigabyte, and I'm going to be seeing if we can use Afterburner to squeeze a bit more performance out of this card. Come along guys, and we'll see how we get on. So we're going to need a couple of things. Firstly, we're going to need a GPU. Like I said, I'm going to be using the 1060 that I used on my previous comparison video. Also going to be using a system, and I'm going to be using my i5 8600K, which is currently on my test bench. And if you haven't seen me build that, I'm going to put a link for that up in the top corner. So also we're going to need Afterburner, and we're also going to need something to benchmark it with. I'm going to be using Heaven Benchmark. I know it's an older version of a benchmarking utility and it's only DirectX 11, but it gives us a really good understanding of how much performance we're getting out of our GPU. So let's get going guys, and we'll see how things turn out. So the first thing I'm going to do is I'm going to get us a baseline. So I'm going to run Heaven Benchmark, and I'm going to run it with everything set as standard. So therefore there's been no improvements to anything. The CPU is running as standard, the GPU is running standard, there's been no overclocks, nothing at all. So I'm going to give this a benchmark, and this is going to give us our baseline score, which we aim to improve on. So I'm going to be using the benchmark utility within Heaven Benchmark, which is going to run through a whole 2016 scene cycle and give us a score at the end of it. Once this is done, I'll be right back. Okay, well that's finished running, and it's given us a score of 2123 and an average FPS of 84.3. So that's our baseline, that's what we're going to start with, and now we're going to see if we can do some tweaking to get this improved a little bit. Okay, so now we're going to fire up Afterburner, and we're going to go through some of the settings on there, and we're going to see what we can improve, what we can adjust to actually get some improvements from our graphics card. So when you first open up Afterburner, you'll see it's giving us a whole bunch of information about our GPU. It's giving us the core clock, and it's giving us the memory clock on the left hand side, and it's giving us the voltage and the temperature on the right hand side. We also have a bunch of sliders here in the middle. We have core voltage, power limit, temp limit, core clock and memory clock. So firstly what we're going to be doing is we're going to be moving all the top three sliders all the way to the right. So that's going to be the core voltage, the power limit and the temperature limit. Now when we move the temperature limit or the power limit, you can see that the two of them move in comparison with each other. That's because they're locked together. I would recommend keeping these locked together. That way you can't increase one without increasing the other. So we're going to move them all the way to the right. So we're basically saying to the GPU that it can give itself 116% of regular power, and it can temperature up to 92 degrees C. We're never going to hit 92 degrees C, so you don't need to worry about that being really high. And we're also going to move the core voltage all the way to the right up to 100. What this means is it's going to be able to give it 100% of core voltage at a lower core clock speed. What we're going to do is hit the apply button, the little check mark in the bottom right hand corner, to apply those settings, and then we're going to run the benchmark again and see if that's given us any kind of improvement. Okay, so that gave us a slight improvement on the baseline of 84.3. We got an 84.8, and you can see the score's gone up to 2137 as opposed to 2123. So that basically all we're doing now is letting the graphics card overclock itself based on its thermal headroom, and now what we're going to try and do is see if we can push it a little bit further. Okay, so what we're going to do now is we're going to start incrementing the core clock and the memory clock. That way we're going to basically overclock it. Currently it's running at, you can see the core clock is running at 999 megahertz, so it's just under 1 gigahertz. Obviously that's not under load, so that's going to go up as we put load underneath it. The memory clock is running at 4000 megahertz or 4 gigahertz. Again, we're going to be increasing the core clock and the memory clock. One thing to remember though is you do not want to click this startup button here at the bottom left hand corner, because what that means is if you do accidentally put a massive overclock on, which then becomes unstable for your graphics card, as soon as you restart your machine, it's going to try and apply that. So until we get things running stable and how we want it, it's best to leave this startup button unchecked. Okay, so we're going to start off by adding a core clock overclock. We're going to start off by running a core overclock of 100 megahertz. But what we're going to do is we're actually going to do this whilst we're running Heaven Benchmark in a loop. That way we can see if we get any kind of artifacting, stuttering, or any other kind of abnormality in the benchmark. So as you can see, I've got Heaven Benchmark running in a loop. So I'm now going to go ahead and add a 100 megahertz core overclock. Simply double click on the 0 next to the core clock slider, and then just type in 100, hit return, and then just hit the check mark to apply that. you'll notice that our core clock has gone up to just over 2000 megahertz, which is just around 2 gigahertz. We can see from the Heaven benchmark that there's no stuttering, there's no artifacting. So for the purposes of testing, we can say this is reasonably stable. Obviously true stability is only actually gained when you've checked every single game that you play with any kind of overclock that you do. That's when you know you're 100% stable. So I'm going to try and bump this up by another 50. And again, hit the check mark. And again, we don't seem to have any kind of stuttering, any kind of, there we go. There's our first stutter. So 150 is a little too much. Okay, so I've dialed our overclock now down to 130 megahertz. So we're running at just over 2 gigahertz, 2050 megahertz or thereabouts to be precise. And we can see it's reasonably stable. There's no artifacting, there's no marks on the screen, there's no stuttering. So we can safely say that that's a reasonably stable for the purposes of understanding where we actually are as a baseline overclock. So now we've got that working, what we're going to do is we're going to do the same thing for the memory overclock. So again, we're going to click on the 0 next to the memory clock and we're going to type in 200 and hit return, and then we're going to hit the apply button. And then we're going to let that run for a few minutes and we're going to see if there's any kind of stuttering on the picture. You can always go a little bit more aggressively with the memory clock because the memory chips are actually solid state. They're able to take an awful lot more overclock than the CPU, than the actual GPU itself is. So I'm going to be going up in 200 increments until we get to a point where it fails like it did earlier with the CPU. Then I'll dial it back until we find something that's relatively stable. Then I'll run a benchmark and I'll see if we've made any improvement. Okay, so I've managed to get the overclock on the memory done now. So I started going up in 200 increments and I ended up getting to 600, and I thought I'd start going a little bit slower. So I went up in 100 increments. When I got to 700 megahertz, I noticed it started to stutter just a little bit. So I thought I'll dial it back. So I've dialed it back to 650 megahertz, which means we're now overclocking the memory on our GPU by 650 megahertz, and we're overclocking the GPU by 130 megahertz. This seemed fairly stable, so I'm now going to run a benchmark and we can see how much of an improvement we've made, if any. Okay, so I've done a few more rounds of benchmarking. It turns out it wasn't the memory overclock that was causing the instability, it was the GPU overclock. So I've dropped that down from 130 megahertz down to 125. Reran the benchmarks, and I was able to push the memory overclock to 760 megahertz as opposed to the 650 which it was earlier. So I reran the benchmark and that gave me an average FPS score of 93.4. Sorry, FPS of 93.4 with a score of 2354. And if we compare that to the original, the FPS of 84.3 and 2123, that's an improvement of a little over 10%. And that improvement was entirely free. Didn't cost me a single penny, just a little bit of my time and a little bit of effort in the benchmarking. So that just goes to show, with a little bit of time, you can get an improved performance out of your GPU. Now I was doing this with the GTX 1060, which is the Pascal architecture. Now I know the RTX 20 series, which is the Turing architecture, respond to overclock a little bit better. They seem to be able to be pushed a little further before they become unstable. So if you had a 2060, for example, or something like that, you'd be able to get quite a bit more horsepower out of it. I managed to overclock my 2060 and got about 18% better performance out of it. Granted, it was on water cooling, so I didn't have an issue with heat, but it just goes to show you that it certainly can be done. Don't forget, guys, stability is dependent on the user. So your machine is actually only going to be stable when you've used it and you've tested it on everything that you use your computer for. So that means every single game that you play using the settings that you normally play on. At that point, you can then say that the overclock is stable. And it's only then that I would really hit that button in Afterburner that says apply these settings on startup. Otherwise, you might get caught out with the settings that's a little bit unstable and it's going to cause your system to crash as soon as it fires up. It's fairly easy to fix that. You just need to then start your Windows in safe mode and then just delete Afterburner and then reinstall it and start again from scratch. Depending on what your GPU is, depending on what your machine is, how much RAM you've got, what your CPU is and how fast it's running, so your mileage may vary, your results may differ to mine, but it's certainly worth giving it a go. So hopefully this video has given you a little bit of confidence to have a go at trying it yourself. And don't forget, with the new 3000 GPUs coming out from NVIDIA anytime soon, there's going to be an influx of the 20 series on the market where people are getting rid of theirs to upgrade to the new versions. It might be an ideal time to pick up an old 2060, get a nice good overclock on it, and then give those 30 series cards a run for their money at half the price. I hope you liked the video. I hope you found it useful. Don't forget to hit the like button if you liked it. Leave some comments down below. What graphics card are you using? Have you managed to overclock them? If so, what kind of performance are you getting out of your card? Don't forget to hit the subscribe button and also the bell notification to be notified when I post more videos. Thanks for watching, guys. I'll see you on the next one.